Hello, welcome to our embedded project of this year. We are a team of 4. We are Mohamed Halawa, Omnia Ismail, Mohamed Omar, and myself, Mohamed Attwa. Let me give you an introduction about our project. Firstly, we thought of this project to help handicapped people. Most of handicapped people cannot drive cars, so we thought of a car that can be driven wirelessly through a joystick. And also we thought to help handicapped people to stop their cars with this ultrasonic sensor that detects any obstacle ahead to avoid accidents and death. Also, it has an option that can be applied in the future and it will be very helpful. It can track a line and detect the line and walk through it. Future application for this can be that the car can be driven from any point dropped in the map to any point dropped also in the map automatically. And now Mohamed Omar, my colleague, will talk to you and show you a demo of our project.
Okay, now we will see the first thing, how the car tracked the line. First, we will turn on the calibration by pressing on that button. Now it calibrates on the black line you see here, and it will automatically track the black line. Okay. Now, secondly, we'll see how we will control the RC car manually, and how the obstacle detector will work and the sound buzzer will work whenever an obstacle comes in front of the car. So when an obstacle comes in front of the car stops working and the sound buzzer is activated.
The components of our project are 12 volt battery, wireless module, joystick, the Arduino transmitter, Arduino receiver, and edge bridge, sound buzzer, ultrasonic sensor, and the blind tracker, and 2 motors.
And now I'll talk to you about how this project will work. To wirelessly control this project, you will need these joysticks. The joystick has 4 inputs. The 4 inputs, each one is defined with a different letter, and each letter will be transmitted through this wireless transmitter and the Arduino and the micro unit in the Arduino to the receiver, also another Arduino, and its wireless module. So each letter has different voltage, and when the voltage is sent, it knows it wants to go left or right or forward or backward. Also, for this line tracker, it has 5 pins, 2 pins connected to this breadboard, 2 pins, 1 VCC and 1 ground. Another 2 is for the Arduino to detect the white and the black line. This ultrasonic sensor also connected to the breadboard, the edge bridge and the Arduino to stop the car. And finally we have these 2 motors. The 2 motors, one for the right wheel and one for the left wheel. Dynamically, if we want to move forward, both motors forward. If we want to move backward, both motors backward. If we want to move right, the right will move backward and the left will move forward, and vice versa.
Our code is mainly divided into 2 classes, the receiver and the transmitter. First, we will talk about the receiver. As any familiar class, we will define our variables first, and then we will talk about our methods. Our variables, we made a various number of variables, each for a different action sensed by our hardware devices. We have five functions for directing our car. We have backward, forward, left, right, stop, and track. we have the incoming byte mode, incoming byte that we will be importing from the other class, the transmitter, and the mode, in which we will control later on. We have mainly two methods: method setup and method looping. The first method setup, it's mainly using the predefined functions, pen mode, to control our directions and our actions through the whole process. Analog write is a predefined function also. We use it because the microcontroller produces either 0 or 5 voltages. We use analog write instead of digital write to vary between the extreme and the minimum voltages, in which we will be using later on in our movement. Method loop is mainly the inner core of our all actions. We use it to command our to produce our commands for either left, right, or any of the 5 directions. First, we will check for the incoming signal using the predefined function serial available, and then we will read the incoming letter, the incoming bytes serial.read. Then we will make if condition. If incoming byte equal t, we have the letter. When we use the joystick, we press the joystick, we get the letter t. We must first change the mode into 1 to avoid collapsing into other if conditions or other cases. And we will light the LED to indicate in which mode we are on. Else, we will turn off the LED and we will switch our mode into 0. Then we will check for the incoming byte we have talked about previously that we will be receiving from the transmitter class. The incoming byte is very important. If the incoming byte is F, it's a very different case, because we will be using the sensing functionality while moving forward, 2 actions at the same time. So we need to check first at the ultrasonic receiver. Using the digital read ultra, we will check the condition of the ultrasonic receiver. Then we will move forward if it's true. And we'll make the buzz 0, so we will stop the voice of the buzz. Else, we'll stop moving forward and we'll turn on the buzz. Otherwise, there is the typical and familiar directions: backward, if the incoming byte B, left if incoming byte L, and so on. Then this if conditions is followed by the first if conditions we have in our method, in which we will be switching to the trackline mode. This if condition is about our trackline mode and followed by this if condition. If mode equal 1, we will digital read the ultrasonic and make track mode. Yeah. Then we have the typical directional functions: the backward, forward, left, right, and stop. If you asked about the attributes we're using in the digital write 0110, we have concluded these attributes based on our testing the H bridge. And then that's it. The ending of our receiver class. The transmitter class is very complicated, since we define the transmitter class is very complicated, since we first define our maximum and the minimum voltage, and based on these voltages and our detecting hardware devices, we vary our speed and send the incoming byte to the other classes. It's very systematic, and we use the same technique concerning all directions.